Welcome back to the next part of the story about the Siberian hunter-gatherers we were focused on in the last video. Recall this is where we are in the world, and that we're interested into biologically and culturally distinct hunter-gatherer populations, the earlier Kitoi and the later Isakova-Serova-Glaskovo, abbreviated as ISG. We're not done exploring the dietary practices of these groups. Perhaps dietary factors were a part of the cause of the disappearance of the Kitoi or arrival of the ISG. Stable isotope research on several hundred skeletons conducted by Dr. Ann Katzenberg and colleagues has elucidated much about their diets. Not surprisingly, fish were the main source of food. Groups living closer to the shores of the lake have stable isotope values that reflect the consumption of more lake fish, while groups living farther from the lake along the rivers consumed more river fish. The lake ecosystem has been found to exhibit considerable isotopic variation both within a fish species as well as between species. And this phenomenon has allowed for the investigation of the types of fish that people were targeting. As well, people living in this region, the Little Sea region, have the most isotopic evidence for the consumption of freshwater bicolor seal. The seal was an important source of not just protein, but also fat. Terrestrial mammals, including roe deer, red deer, and moose, as well as smaller mammals, were also a part of the diet. And finally, we have limited evidence for which plant foods were consumed because all plants are of the C3 type, and the high isotopic values caused by meat and fish effectively swamp the isotopic contribution of the plant foods, but likely plant foods include seasonally available berries, mushrooms, and pine nuts. So, are there differences between the two populations? The answer is yes, but it's not a difference characterized by all or nothing choices. Rather, it's a difference in emphasis. The later ISG were more reliant on terrestrial mammals and less reliant on high trophic level fish. We can conclude that both populations were heavily reliant upon fish, but the specific species and habitats of the fish were somewhat variable, as was the importance of terrestrial mammals. But what of the adequacy of the diet? Basically, we have to consider not only the quantity of food, but also the quality, in terms of there being enough carbohydrates, fat, and protein, as well as sufficient amounts of vitamins and minerals. We have the following expectations. The diet likely had an ample amount of protein year-round. The freshwater seal would have been a very good source of fat in the spring, as would some fish and terrestrial mammals at certain times of the year, but fat may have been scarce in the winter. And plant foods providing carbohydrates would have been lacking in the winter. One way of gauging the adequacy of diet is to use a pathological lesion that forms in the teeth called enamel hypoplasia. Recall that enamel hypoplasia is a non-specific stress marker, meaning it forms as a result of a prolonged and pronounced period of physiological stress, like famine or a serious illness. I undertook the analysis of every tooth from over 200 skeletons for abnormal deficiencies in enamel thickness. These can take the form of pits within the enamel, either single or multiple, or clustered and spread out as seen here. Or more commonly, indented lines in the tooth running horizontally, seen here. And these are called linear enamel hypoplasia. With linear enamel hypoplasia, it's possible to figure out the approximate age of the person when the defect formed. Basically, as you've heard, we know the age when different teeth form. For example, as you see here in a publication by Reed and Dean, a tooth crown can be divided into 10 parts called deciles, and an age of formation given to each decile. So, for every linear enamel hypoplasia, I could determine its age of formation. On to the results. First, in terms of the overall prevalence rate, we can see the two large Kitoi sites had quite high rates. And this means that 80 to 90% of the children in these populations experienced but survived at least one serious stress episode. In the ISG population, some sites were better off than others. And in terms of the average age of enamel hypoplasia formation, the two populations were quite similar. The Ketoi averaged 3.2 years and the ISG 3.3 years. But most importantly, when I was scoring the teeth, I was quickly struck by how many had not one or two, but 3, 4, even 5 linear enamel hypoplasias within the same tooth. And if you looked across the teeth forming at different ages, you could see that the hypoplasias had formed during nearly the entire period of tooth formation. When I quantified the amount of time between these repetitive hypoplasias, the biggest differences between populations became apparent. As you could see in this graph, the early Neolithic Ketoi had a much higher frequency of individuals with multiple linear enamel hypoplasias than the late Neolithic peoples. The Bronze Age actually became quite similar to the early Neolithic Ketoi. Some Ketoi individuals had 8 separate stress events in their teeth. Finally, I could see how much time had elapsed between consecutive stress events. As you can see in this table, for many, anywhere from 10 to 13 months elapsed between consecutive defects. So the major stressful period was occurring approximately every year. When do you think people living in a cold, boreal forest environment might experience the most stress? If you are thinking winter, you are on the right track. Probably the time of year that was the most stressful for these people was the late winter and early spring. This is based on lots of research with historic and recent northern peoples that has documented how difficult it is to obtain enough of the right food in this time when terrestrial mammals are very lean, stored foods are exhausted, fishing is more difficult and less productive, and of course plant foods are not yet available. It may have been possible to obtain enough protein, but not enough fat and carbohydrates, causing serious malnutrition. In fact, individuals could have even experienced protein toxicity. So the hypoplasia data suggests that the Ketoi were more affected by seasonal nutritional stress than the ISG. And perhaps this, more than anything, led to the declining population of Ketoi, maybe deciding to move elsewhere and abandon the shores of Lake Baikal in search of a more reliable and consistent diet. In this video, you have first learned about stable isotope research conducted on Lake Baikal, Siberia hunter-gatherers to reconstruct what they were eating. Second, you learned about enamel hypoplasia and how it can be an indicator of seasonal nutritional stress. In the next video, we're also going to focus on a pathological lesion in the teeth, in this case caries, which you probably know as cavities, and how the occurrence and pattern of caries can tell us a lot about what past peoples were eating.